All right, so thank you. So now for something a little bit different. I'm not going to move around. I'm going to lock right into this podium and stare into that monitor right there. Okay, I'm just kidding. I'm going to move around. So what I'm going to do is I'm going to talk to you a little bit about our great challenge we have before us as NASA, and I'm going to talk to you about how you can be a part of that challenge, and I'm going to talk to you about how we want you to be part of that challenge. A big part of the message we're going to talk about today is how you partner with NASA. Sometimes that can seem a bit challenging, and sometimes it is a bit challenging, but what you need to know is that we want to make that easier for you. We want to find a belly button for you so you can make a connection. So you can make a connection. We're going to have a panel this afternoon and talk a little bit more about that. You can make that connection and find that person and help you navigate through those waters. So I'm going to guess which one of these buttons is the right one. Okay, first, why go to the moon? So this is probably old news to everybody. There's nothing new we're going to see on here. But I do want to point a couple of things out. Open up new commercial markets. We heard from the previous speaker. There's great opportunity out in space. And it isn't just out in space. It's those things you can mature and develop, those things that we will use to achieve our mission of going on to Mars and further, that will be applicable here on Earth and for other businesses that we haven't even thought of before. The other thing is the inspiration. So when you get a room full of folks like this together, you think, where's that next innovation going to come from? Where's that next idea that we never even thought about? So we need to feed that, so that inspiration. You can probably tell I'm a member of the Apollo generation, and I was inspired and excited by that. Now we're going to get to what we're going to do going further with the Artemis generation. Okay, so for us going to the moon, there's three things we want to be able to do. We want to be able to understand operations when I'm a few days away from home planet. Not a few hours, but a few days. How do I operate? How do I get my systems to work together? How do I use AI? How do I use autonomous systems? How do I use crewed systems? Crew health and safety. We want this to be a viable market for business and industry. We have to demonstrate that with our crews, that I can get them there, they can function, they can work, they can overcome the environments of being in space or on another planetary body. And also they can be robust enough for when life intervenes and we need to take some kind of action. And the last piece is that technology development. This is a key part of what we should be doing. So as the NASA from the previous 60 years, for a lot of that time, NASA was the only player in town. NASA and DoD were the only players in town. For the next 60 years, the next 100 years, that is not going to be the case. And that is a great idea. I can assure you that when I came here today, I did not commission a team to build an airplane and start an airline and fly me here. I went and brought a ticket. And that's what we want to think about for space development. We, NASA, want to be leveraging what private industry is doing so we can go out further and go on and do that next horizon thing. So, to get there, we're going to do the Artemis program. So Artemis is a sister of Apollo. I'll let you read that in Greek mythology. So again, that's where the Artemis generation comes into play. So do we want to go to someplace different than we've been before, the South Pole, and we want to set that horizon goal to Mars? So when you think of NASA, you should think of what's the next thing. So while we're going to use the moon as a stepping stone to get to Mars, once we've gotten to the moon and on to Mars, it's deeper into the solar system, both robotically and crewed. And as we've gone deeper into the solar system, it's interstellar travel. And it sounds like, science fiction, but everything we do, everything we take advantage of today was science fiction for somebody at some point. So you should think of NASA as that next step. And what we want to do is talk to you about how do we make that easier for you to engage with us? How do we make it so that you're part of that journey with us? So you're going to see this slide and this backdrop several times. While I do not have a bottle of wine to give you, I can offer my NASA pin as a prize. Okay, it's not as good as a bottle of wine, but there's something in that picture I want you to take from that. And a lot of people take a lot of different things from that picture, and I'm not going to tell you till the end, or maybe I'll wait till this afternoon to encourage you to come to our panel session. But there's a message in that picture that I think sometimes people miss when they think about NASA. So I'm going to talk about Artemis in the phase 1 portion. So we're going to leverage the Orion Space Vehicle SLS rocket to do the Artemis 1, 2, and 3 missions. The first mission will be demonstrating the capabilities uncrewed, and then a crewed vehicle to go, our crewed mission to go around the moon. and then finally in 2024 to land on the moon with the first woman and the next man on the moon. In parallel with that, we'll also be developing technologies for the gateway. This will be a minimal gateway so we can develop those operations in orbit around the planetary body. So these things will go on in parallel together. Okay, I talked about SLS and Orion. I'm going through these intentionally so we can get a little further in the program, and the gateway. And you notice that the gateway, while in time, over time, well beyond this time frame, it will expand and be larger. It will demonstrate how we operate around a planetary body. And one can imagine something similar around a Mars or another planetary body. But right now the gateway is that place where we will dock astronauts and they will get into the lunar transit, descent and ascent module and go down to the surface. And we'll be able to reuse those modules over and over again. Okay, so I'm going to spend a little time on this chart. So as you see the timeline between now and 2024, we have 3 Artemis missions, 2 Gateway missions, and a human lander system mission. And those missions will be done, as you'll see, we're going to use Orion and SLS for the Artemis 1, 2, and 3 missions. For our Gateway elements, we're going to use commercial entities to launch those up into the Gateway and put those in position before we send crew there. What you also should notice is along the bottom, in parallel at the same time, we're going to be sending robotic missions to the moon to learn how to function, learn some science from the moon, to learn what it is we can do on the moon, and also learn some things about when we actually do land on the moon. We also have commercial lunar payload services. This is where private industries are going to develop their technologies and demonstrate how those things can use to advance the technologies going forward. So that's phase 1 for the Artemis program. Okay, next one is Artemis III, starting with the launch of the SLS system and Orion capsule, moving on to a crewed mission, a 3-day mission onto the lunar surface, and with the lunar transfer module, take that down to the surface of the moon, and again crewed and return safely. The key part about this is that, and I think it's in the next chart, not only can we do lunar science from the moon, but you can imagine Earth science from the moon also. So we have a big stationary platform that we're going to use. And you'll see a lot of that. And I'm going to go on. And again, here's this chart again. I want you guys to kind of look at that and see what moves you, what resonates with you on that chart. Okay, so the next piece for the phase 2 is the sustainability. Now, this is a critical part of what we're doing going forward. So it's one thing to go to the moon, land on the moon, plant a flag, maybe leave a little infrastructure there. It's another thing to make the moon a place that we stay. So over the course of from 2024 and through about the 2029 time frame, we will demonstrate the ability to live and prosper on another planetary body. And that should be pretty significant because the things we learn on the moon will be those tools, techniques, technologies that we'll learn for landing and living on the Martian surface. So again, I have another chart here for phase 2, and you'll see there's an Artemis 4, 5, and 6, and this is our sustainment period. This is where we're going to need you to help us develop some of the technologies that we're going to use to go even beyond what we do, and this is where you can leverage some things we've done. So NASA has been around for 60 years. You have a chance to leverage some of those technologies, some of those developments. As a federal government laboratory, it's part of our job to reach really far out and take some of the risks that you may not be able to take, but we can partner with what you've learned and what you've done with what we've learned and really do some groundbreaking work going on not only to the lunar surface but on to Mars and forward. Okay, and next to last piece I want to talk about is the science on the lunar surface. So there's a lot of things to learn, especially if we're going to go to planetary bodies. How do I handle the regolith? How do I handle the dust? How do I keep a crew healthy? How do I provide them with the resources they're going to need when it's not quite as economical as I would like to take everything with me? Some of the things I'm going to have to build and use when I get there. How would I use the lunar surface as a platform to study this, our home planet? So if I have a nice stable moon and I can stare at the Earth, that would be a good place to study from. If I want to stare out into the universe, if I was on the dark side of the moon, that would be a good place to study from. And so you'll see some of those things going on at the very same time we're doing the Artemis mission. So you see there's lots of work to do, and there's lots of opportunities to partner. So I'm going to challenge my IT person over there because they said when I press this twice, it's going to play a video for you to tell you a little bit of a story. And I told them that if it didn't work, I was going to deflect all the blame over here. So I want everybody to look at them, and I'm going to go ahead and press twice.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
Very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and onto Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
So thank you. I actually didn't want to have to start clapping, but I appreciate that. So that's a nice video. It talks about us, and what I don't want you to take from that is that we means NASA. We means all of us in this room. It means every one of us in the room are going to make this happen. There's very little of this that we NASA are going to do by ourselves, if any. So we need those partnerships. So the capability, the purpose, the change, the responsibility, that's on all of us to be that inspiration going forward. So as we talk about partnerships, I'm going to assume some of you are familiar with our SBIR and our STTR programs. Those are some formal programs that we not only have agency metrics for, but we set internal metrics at our various centers, and we really try to exceed those metrics every time we set them. But that's only one way to partner with NASA. You'll hear a little bit more about that this afternoon. But we have Space Act agreements. That's where two people can meet at a conference like this and find that we have something in common. There's something you're doing that matches what we're doing in terms of our mission. You may have a different application for it. And we can get together and say, how can we share our expertise? And we can do reimbursable agreements. We can do non-reimbursable agreements where we have mutual interests. That's where we can talk. And so part of what you're going to hear this afternoon, I hope, is the idea that we can help you navigate through some of those. We have broad agency announcements. We have a number of tools that will enable you to partner with us and us to partner with you. And maybe I'll dispel another myth. At many of our centers, we are not the lead. We are actually a sub to some of our private entities. So it isn't always NASA taking the lead. When we say partner, we truly do mean partner in finding the role that's best suited for us as a federal government lab that matches the common objectives that we may have with each other. So again, if you leave with nothing else, and I want to commend the Congressman's video remarks, a lot of what he said is about what our future is going to be and how we're going to do this together, and the important part of the commercial and private sector to make those things happen. So we're really about doing that. The other thing is, if you've had a chance to work with NASA in the past, you may have seen that we have a structure and a 60-year history that's behind us. And sometimes it's a little hard to kind of drag that along with us, but we are working really hard to break that up. We're trying to make sure, while we do have to be conscious of the risk, we want to do things safely and within cost and in schedule, we also want to make sure we're balancing that with a benefit. A lot of what we're going to talk about is going to incur some risk. The zero risk option is to lock yourself in the closet and stay there, right? But we're going to move out beyond that, and we're going to try to focus on the benefit. So when we sit and talk to you about the amazing things we can do together, let's have a conversation about the benefit and the impact on us as a federal lab, the impact on you as a private industry, and as we heard several times from several speakers, the impact on humanity. So I have some business cards in my pocket, and on the back of my business card it says we get to reach for new heights to reveal the unknown for the benefit of humankind. I put that on my business card because I get excited every time I think about that. That's what we get to do at NASA, and that's what we want to do with you. So we're going to try to manage our risk. We're going to try to break those structures that aren't helping us all progress into the future, and we're going to be that NASA in the future that leverages what we learned in the past, but we're going to do things in different ways and more informative ways. So with that, that's my final remark, but I think I'm opening up for questions. I'm looking for a nod from the group. Questions? Yes, sir.
I'm really interested. The Lunar Gateway has been proposed and presumably we're moving that way. I'm extremely interested in whether it's going to be tended or crewed on a regular basis as opposed to just tended when we're going on a mission. My concern is the radiation environment. That if you're in where ISS is, you shouldn't have a problem. If you're on the moon, you can bury yourself. We almost lost the Apollo 16 crew. Then have been 2 days later that have been fried on the moon. How do you mitigate that risk in the lunar orbit?
So right now the gateway will be mostly autonomous operations other than when crew's there for a landing. So it'll be autonomous operations. How do we conduct science instruments and put science payloads on board and protect and learn from those. And this will be a learning environment. So most of the time, gateway will be untended. Yes, in the back.
How will you ensure that the Artemis project won't? How will you ensure that the Artemis project won't either be radically changed or scrapped altogether when the new administration?
So while I can't ensure that, I can tell you what we're doing to try to minimize that. So part of the idea of landing on the moon in 2024 is to do it at a pace such that we could weather the political storm that may come every 2 to 4 years. Part of the Artemis, the phase 1 and phase 2, is do something that spans not only what we're doing here, but that tries to drive beyond the politics of destination. Our administrator, if you've had a chance to hear him speak, he talks a lot about the pace at which we'll work at, and also leveraging and working with both ends of Pennsylvania Avenue to make those things happen. So I can't stand here and tell you that we won't hit some bumps in the road, but I can say that as we partner and work with private industry, that is another way to reinforce our ability to deliver on some of these missions. Okay, yes?
You mentioned specifically that elements of the Deep Space Gateway are going to be brought up by commercial rockets, launch vehicles. Why are we doing that commercially? And is that in timeline with the SLS? And if those are capable of reaching the moon, why are we not using those ultimately for our missions to the moon?
So eventually you'll use all the capabilities. So right now SLS is the most powerful rocket in development that will be ready to use and do those missions. You can imagine at some point in the future we will use whatever assets, and that's a comment I made earlier. You know, we didn't build an airplane for me to fly here. I bought a ticket, and you can imagine we'll evolve to that. And what I try to share with folks, if you think back a while, there was a time when we think in terms of aviation that only the government and daredevils went in those crazy flying machines. And now none of us give a second thought to buying a ticket on an airplane and going where we're going, because private industry was ready to take over the development of the vehicles and the operation of those vehicles because it was a business case to close. Well, that's what it should be for us as a federal lab. You know, we will develop those first or push the technologies, but eventually private sector will take over all of that. It's just a timing for those kinds of things. Okay? Other questions? Yes, sir.
Hello, my name is Tim Fernald. I'm a reporter with Quartz. I wanted to ask, obviously last week the leadership of the Artemis program was just shaken up. We saw William Gerstenmaier removed from his position. Now we have a national search to find a new person to take on that job. I know that the Associate Administrator didn't come today, but you're here, so I wanted to ask you, who do you think has the right characteristics for that job? And given that we're not changing the architecture of the Artemis program, what do you think that person can do to make sure we meet the deadlines that have been set out?
So I think the characteristics of that person are somebody that's going to look forward and leverage the greater community to meet that mission goals, and also demonstrate the flexibility as we navigate. I think the earlier question, as we navigate the politics, you have to have a certain skill set to be able to find your way through those waters. So those are the characteristics. And as you know, I'm sure you've read in the announcement, that will be a broad announcement where we're looking out to see how can we leverage again what we've learned over the last 60 years, but also take advantage of what the entrepreneurs and innovators are doing going forward and leverage those for what we're going to deliver going forward. Others? I think there's a question over here. I'm not sure where the microphones
Peter
are.
Erickson, I just wanted to follow up on your statement that
I'm looking for you. Yes. All right. Thank you.
You said SLS is the most powerful rocket in development. Well, we already have a fully developed Falcon Heavy that is more than half the capacity of the Block 1 SLS. And then the BFR Starship, you know, is in development, and it's more than SLS. And considering that Falcon Heavy is 1/10 the cost per launch of SLS, it would seem like I could have 10 times the space program nearly if you guys went initially with a commercial vendor to start putting payloads into the lunar area. So I'm curious about that. And then the second question is, it appears that most of the CLPS payloads are going not to the poles, and I'm just curious why you wouldn't be putting footprints down on the South Pole now, since that's the direction.
So I think I can answer the second part first. So the CLIPS programs looks at those technologies, a trade-off where we're going to make those landings. So while the first few, what does that demonstrate or you can do for CLIPS to land at maybe a non-South Pole site, but there will be a number of them, as was in one of my charts, where we'll be targeting the South Pole. So that's just an evolution of the program. And can you give me your first part of your question again?
So your statement was that
Yes. Okay.
SLS is the most powerful rocket in development. It would appear to me like Starship is actually a larger payload also in development, and that you have already Falcon Heavy with 66 tons is more than half what you could have, and it's 1/10 the per mission cost. Why isn't NASA being more aggressively about using Falcon Heavy in its architecture?
So using the systems that we've developed and put some investment in to do that first set of Artemis missions, they will be ready to go on those timescales. And I believe I answered a question over here. At some point when those other vehicles are ready and demonstrating that heavy lift capacity for a human-rated vehicle, then we will transition to those. And you'll see, I can't go back to the chart, but you'll see in the chart that we do plan to use commercial rockets where they're available and where they're there, again, for a human-rated capability. Yes, here in the center.
So we saw under Griffin the start of some of the COTS program, and then, you know, basically we've now seen commercial crew, and now we're looking at CLIPS. I was wondering if you might be able to just speculate on the future of some of these commercial-driven programs, and if you see any, you know, we're looking at the moon now, we're looking for transportation, but are we going to be looking at, say, habitats or power or other things like that? Do you think NASA's going to continue, if it's successful, to proliferate this, or is it going to kind of stay more within NASA?
Yes. So the point being is, as things mature and commercial entities are available, that should grow, and that's probably one that we don't have to worry about the political swings, because as private industry is able to take on those roles, they will take on those roles, because the taxpayer, the federal laboratory investment should be on those other things. So by all means, it would be all of those things. So I think this will survive. I think when Mike started it, there weren't as many players available, but because he started that and you had other things going on, commercial crew, that, you know, got the industry going and got interested players. Now we have even more interested players. So you'll see that natural growing again. I use the parallel or the analogy of the aviation industry. Federal government daredevils that kind of dabbled in it until it became there was a business case that closed. And you can imagine that for everything going forward. Not only just getting there, but the habitats will build. The question I had about the commercial crew, some of those folks will be demonstrating technologies that may be the providers for us in some of the things that we use and do. Again, as we go out further to that next thing. All right, yes.
Hi there, Sean Mahoney with Space Frontier Foundation, amongst other things. You've got a room full of people who are looking to advance the settlement of space, and you've given us some idea of what that roadmap looks like for NASA. The two questions, it's the same one. What can we do to help you? One, explain that outside and understand part of that is articulating the benefit of NASA to the LMO, things like that. The other one is, what can we do to help those that are trying to move the agency forward? How can we, as the operators that are working with you, best advance this objective? And maybe if you have anything from a personal standpoint of what you've seen, what has worked really well in kind of helping accomplish these big goals?
Yeah, so I think your advocacy, and it goes to I think one of the first or second questions we got, your advocacy on the value of this. I won't say a lot of times, but several times I've been out to have conversations with folks, and they hear numbers like billions of dollars to do thing A and a few more billion to do thing B. And I try to remind them that I can promise them that not $1 was taped to any vehicle that landed on Mars. All that work, all that investment was here on the home planet. I also typically will take out my cell phone and say that, you know, while NASA certainly didn't invent the cell phone, but it did have a need for small, low-power electronics as we were developing and going through the Apollo time frame, that private industry then took and developed technologies that we take for granted right now today. So your advocacy that going to space, and as was said earlier, going to space isn't just about our exploration going to space, but it's about driving the economy, driving interest and excitement here on the planet, home planet. So for this group, to what you can do to continue to advocate for the missions that we're doing and continue to hold us accountable. So if you find us getting stuck in that this is the way it's always been done before, call us out on it. Show us new ways we can do things, and then partner with us. Again, we're going to talk in a panel this afternoon about those partnerships. Sit down and have a conversation with somebody. And while we're going to work really hard to make that a lot smoother and cleaner to get to us, it's not going to be perfect. There's still a big bureaucracy that we'll manage, but we are committed to trying to, with you, to remove some of that so we can get something done together. So I would say advocacy will be one of the best things you can do for us. Yes.
Hi there, my name is Mike Vinge, and I'm with NASA Kennedy Space Center, and I represent the SBIR program. And just to echo what he's speaking about, this afternoon we'll have the opportunity to get a lot more specific feedback from everybody. Just specific to this one question, I want to bring something up. We have a certain kind of rhythm within the program, within the agency, where we periodically renew things. You've heard of decadal surveys. You have technology roadmaps that get reviewed probably about every 5 years, roughly speaking. The SBIR program is an interesting thing because each year it's a brand new, fresh scrub of the technology that's needed, and the dialogue that we have with industry is really important for us, particularly in situations like this where we've got such a strong subject to discuss, frankly. So each year the SBIR solicitation can give you an essence of an example of what it is that we think is we're interested in contributing, and where the edge is where we're not really sure and we need your help. So that solicitation is available at, I think you can just type in NASA SBIR on most search engines. You get to the public-facing website, and you're looking for the 2019 solicitation. We just did awards for it this year, and there's more details about that later this afternoon, so I don't want to kill this, but it's a very specific, deep technological dive if you want to see what we're talking about on a lot of different research subjects. So thank you.
Thank you. And you're going to hear a couple of times, in addition to the panels that we've both talked about, we're going to have a social mixer afterward from 3:15 to 4:15, where we can just sit around at tables like this and just chat about the art of the possible. Yes?
Hi, my question is more about international partnerships. I know there's been a lot of focus on going to Mars, beyond Moon, and cost is definitely a big factor. And I know we have some partnerships in place regarding the Deep Space Gateway, which are essentially the same partners for ISS. So my question is, like, beyond phase 1, are you guys open to partnering with new players such as Israel or ISRO, who are kind of famous for doing missions at a small, like at a low cost? So what's the agency's, directive in those kind of like partnerships in future?
So we do have relationships with ISRO. We do some missions with them more on the Earth science, studying the Earth, but we are aware of the capabilities. And I would say from an agency perspective, the idea of partners that want to bring, again, just like I was describing with this group, we have some common interests where we can leverage and take advantage of each other's skills to meet those common interests. Those are always going to be open, and you hear the administrator talk about that. I think it was at National Space, the administrator sat down with probably a dozen folks leaders from different space agencies to talk about that exact thing. So while we have this architecture and this way we're going to move forward, it'll evolve before us what are the actual partners and how that actually happens. And while the moon is the moon on the way to Mars is a focus, I think the even better focus is out into deep solar system and interstellar travel. So as long as we're looking out forward, driving, it's going to be that better for humankind kind of thing. Okay. And there's a guy holding a big sign up there, so that either means I have 30 minutes left or 30 seconds. Depends on you guys. If you have no more questions, it's 30 seconds because I don't want to stand here for a half an hour with no questions. Yes?
Hi, thanks for taking the question. I'm just curious, given that the U.S. is returning to the moon, China is, of course, there are multiple private companies and unknown actors probably in the next few years that will be heading up there into orbit, possibly touching down, possibly making a semi-permanent base or whatever. Is there any kind of extra coordination at the international level that needs to be established via international space organizations or UN or anything like that? How are we going to coordinate these multiple nations and organizations near the moon?
So the answer to your question, yes, but they're as complex as our coordination and being able to do things together here on Earth. So we'll have to sit down as human beings and get together and work out how do we set the guidelines. I don't want to say set the rules, but how do we set the guidelines for how we function together on the lunar surface or as we expand out into the solar system. So absolutely, and administrators talked about that. The meeting I just referenced was a little bit of those conversations, and obviously the geopolitical situation always comes into play, but I think there's that, if we can get that common interest of, or that common goal of what's the benefit of humankind, I think there's a place to get there. Or an opportunity to get there. But it is going to be complex, and we're going to do a little bit, we're going to learn a little bit, and maybe we'll skin our knee a couple of times, and hopefully we can get a little better with that. But absolutely, that'll probably be as big a challenge as the technology development. but it is something we have to overcome. I think it's too important not to work out all those pieces. And a lot of what we're doing, and I would say after you leave this conference and you've talked to us, you've heard our panel discussions, you've talked to us afterwards, and you've reached out to somebody at NASA and you kind of bumped your head against the wall a couple of times, don't give up on us. Take me at heart when I say we really want to make this work, but we're not going to get it right every time, but it is our goal to get it right so it's almost transparent to you. Okay, with that, I don't know if my 30 seconds are up. So thank you very much. Wait. Thank you. So I used to work as a recording engineer in a previous career, and it would always amaze me that, when you go to a concert and the group will do their thing and they'll walk off the stage and then they'll come back because the audience just drug them out there. You had to have them. But it was all rehearsed and they were going to do that no matter if one person clapped or other. So I guess I'm back on stage. So I'll tell a few jokes until I get some questions. Yes, sir.
We have a group here from the community college over in Kitsap Peninsula, Olympic College, and 2 high school districts. So one of the reasons we're here is to find out how we can create an educational consortium in our region focused on space. And does NASA have anything that might be helpful?
Absolutely. So I think it's not just NASA, it's probably across the nation. There are space grants, fill in the name of your space grants, and NASA and the federal government provides funding. At NASA Langley, we have a number of programs where we not only bring in rising high school juniors and rising high school seniors. They take a course over half the school year, and a small group of those, about 150 to 200, are selected for a 1-week program where they'll either develop a Mars mission, and it's a residence program, or a 1-week program where they'll launch a CubeSat or something, obviously simulate it. We also have programs with our community college. I'm a community college graduate, wherever the community college students are, where we bring in those students because they're going to be non-traditional students, and some of them may have a family that they're raising. So it's not always about that 4.0 GPA. It's about what skills do you bring to the table. And what we do is let them come in and be exposed to the kind of things we do. So whether they want to stay with that 2-year degree or go on to advanced degrees, there's a role for them at NASA and in the industry as a whole. So we certainly can talk afterwards, but the Space Grant Program is a place to start. We do a great deal of outreach. One of my personal passions is about the inspiration piece of this message. I will go out and talk to whoever will listen, to include the 4-year-olds, because that's where you infect their minds with the art of the possible and you remove the can't. Because some of those 4-year-olds are being told today what they cannot do. So we want to get rid of all that. We can't change the people that are telling them those things, but we can show them something different. So that's something I have passion about. And I also think in the middle school, where some of our students, we talked about, I think the congressman talked about the workforce of the future, that if we don't get them excited in middle school, because by the time I'm ready to hire them, those folks have already made their choices a long time ago. I want to grow that pool so I have lots of people to hire. The fact that we're all fighting to get those hires, and they're coming up with new ideas and new ways. And every time I talk to a student group, I will literally give my card to anyone so that if somebody in my organization in NASA says, when they get asked, why are you doing it that way, and they say, because we've always done it that way, then I want to talk to that person and let that student lead that activity, because that can't be our future. We want to leverage and learn from the past, but that can't be our future. And those are the folks that are going to put us on Mars. Those are the folks that are going to take us deep into the solar system. Those are the folks that are going to deliver the interstellar travel. So yes, there are lots of programs. We have an Office of STEM Engagement. I'm careful because of our names. While the name changes sometimes, it is about that inspiration and seeding that workforce of the future. And again, we don't know where that magic sauce is coming from for our next invention.
One of the other things I'm not sure if you might be aware of is the NASA iTech program that's run out of HQ. If you're aware of that, because we did have an event at Langley a couple of years ago, I think some of the entrepreneurs here would be, they might be able to make great use of that.
Okay, so we're going to be at our social. I would encourage you to come and and chat with us and chat with any of us to help you out. And one thing, and I don't know how it feels outside of NASA, there are 10 NASA field centers, but you should always just think of just one NASA. So if you come to one of us, and I happen to be at Langley, and you're interested in something that's at Glenn or at Goddard or at Johnson, I still can be the person you come to because I'm going to help you connect with that person. So it is about one NASA, so thank you for that. I have two back here. Yes.
Just to add a little bit to that, also another way of thinking about the pipeline for the next generation and how to kind of get that kind of continual flow going. So the SBIR program also has the STTR program, and in that situation there is money that goes out to where it has to be a partnership between a research institute and a small business to qualify for those particular subtopics. So there's a good chunk of work out there that unless you are working with the university, you don't even qualify. The flip side of that means that the universities have this real great opportunity to introduce their students that are coming up through their undergraduate and graduate programs to small businesses that are working directly on this. So in some cases, if it's a research institute looking for ways of kind of helping their students coming up and through and kind of thinking 3 to 5 year plans, the STTR program is also something that's really worth looking at.
Thank you. And I'll share one story. So we had an early career individual come to Langley a few years ago, and we were working on a technology for an inflatable decelerator going into planetary bodies with atmospheres. And that was a core mission for us because you're going to need something like that to land large payloads on the surface of a planet like Mars. And that person was assigned to that activity, and he happened to be familiar with the fire in Arizona where some firefighters had lost their lives. And they lost their life because a fire had consumed them, raced by them. The fire moves through the forest fairly quickly, and what their remedy is they carry a little pack so that if the fire does catch up with them, they can kind of dig a place and cover themselves up. Well, the protection they had wasn't sufficient, and they lost their lives. Being familiar with that, he was looking at the technology we were developing because it had to be flexible, lightweight, so you could fold it up like an umbrella and pop it open when you needed it to go through a high heat impulse environment. And he suggested that that technology, excuse me, could be used for the other application. And we were able to allow him and a few of his colleagues to do some research. And we actually passed it on to the U.S. Forest Service, and that may actually be commercialized. So you're talking about a technology that Clayton wouldn't have thought of its application there because Clayton is focused on this mission. But here's somebody coming in with a fresh view and a fresh look at what's going on and saying, here's how you can apply this same technology. So that may literally save some lives on a planet while it helps us land larger payloads on another planet. All right, so I had a question over here. Yes?
Thank you for your time this morning, sir. So going back to the Gateway, we've seen from ISS the incredible research we can get and information we can obtain from orbiting. But in terms of the Gateway, why not just go to the lunar surface with our expectations looking to Mars? When we get to Mars, we most likely are going to try to establish a colony. Why not take early measures and kind of do that on the surface of the moon in order to see how we can build structures to protect against radiation and et cetera?
So we're going to do the second part you said, but what Gateway gives you the advantage of is how do I operate in space away from the planet? So it also gives me a portal where I can take landing vehicles and dock them to Gateway and use them multiple times because I'm refueling them from a Gateway as opposed to going all the way back to Earth. And if I learn how to do those operations well, I may be able to do the similar thing at Mars. So I can use that as a leverage point. So yes, I can go right now and land on, not right now, but I can go quickly and land on Mars, but then we wouldn't have learned the things that we need, again, to go out further. Yes.
Hi, my name is Marisol Garcia, and I also work with Clayton at NASA Langley on the East Coast. And I just wanted to echo, as Clayton mentioned, we do have 10 field centers, and each center has a partnerships belly button that can help you guide through our systems. And pretty much each center also coordinates with our local universities, so we could help point you to the space grant consortia within our region, as well as a lot of internship programs that we support. And as my colleague mentioned already about the SBIR program and the STTR program, we also have your traditional contracting procurement, as well as proposals. We tend to partner with many of us small business and other businesses. So I encourage you to come and visit with us during our networking sessions, so you can learn more about that and the different capabilities and facilities we have at the different centers. Thank you.
Okay. Oh, over here. Yes.
I was wondering, from your point of view, how is the commercial industry doing on key performance metrics like the cost of getting people and payloads into space as we supply the ISS, compared to something we all understand, say for example the space shuttle? Is the commercial industry making advancements here, or are we sort of staying at the same level of performance that NASA's achieved in the past, and if so, why?
No, I think the commercial industry is making advancements. The idea is to lower the cost of getting to space, or even change the way we get to space, and I can see those same advancements when we talk about how we get from point A to B, the propulsion elements of moving around in space. So I think there is progress made. And almost by default, if you even take out going to space and the industry that we're talking about, the more brains I can get on a challenge, the more likely I am to make that more efficient and more effective. And if I add to that the complexities of running a business and returning an investment, there are people going to be actively finding ways, how do I make this more efficient and more effective? And so that by default is going to be better. Yeah, from my perspective, yes.
Just to clarify, so my math says that the commercial industry hasn't beaten the space shuttle yet on getting payloads to the ISS, for example, by about 50%. It's still behind. So are we really succeeding, when we look at the real metrics?
So this is another one of those things where we'll look back and see that we did well or did not. The technology that I talked to you about with the firefighters protection, that was something we developed over a number of years. There's another technology that we've developed for navigational Doppler LiDAR to get systems on a lunar surface so you can help you with your landing. And that's probably going to be part of the CLIPS program. It'll be part of ongoing missions going forward. But that was something that was developed like 15 years ago. So I'm not ready to, I guess you want me to say it's good to go or not good to go. To me, I see there has to be an evolution of how we get there, and or an infusion of here's a new way or different way to do it. I don't know if hopefully I answered your question. Or okay. Yes, I think there's one back here.
Right here.
So you need to put minutes or seconds on there because we've done this before, okay? And I need, what's his name? Because he could have told me it was minutes before I got off stage. Yes. I'm not sure where I'm looking.
Right here.
Okay, I'm looking. Oh, yep, gotcha.
The debris is collecting in Leo, and the station has to dodge about once a year, and about 10% of Leo spacecraft have some debris damage. If this continues, we won't be able to use Leo. Is NASA doing anything to get ahead of this?
Thank you. So orbital debris is going to be a big challenge for us going forward. We have some folks working on technologies to try to minimize the impact of the orbital debris, but it is going to be a big challenge for us going forward. No easy solutions now, but we do have people working in those areas at a number of our centers. So how can we mitigate this problem without adding more things and more items to the problem? So don't have an easy answer for you now, but it is something we're focused on for obvious reasons, be it in LEO or GEO, or even if we get out to those planetary bodies, we need clear paths to travel through. So that is a focus. We actually have an entity at NASA that focuses on that orbital debris challenge. Yes?
Hi, thank you so much for speaking today. My name is Luke Riesbeck. I'm a researcher at the Space Policy Institute at GW. And I'm part of this Artemis generation that I've been hearing so much about. I'm really excited to see this next generation of human spaceflight. So we all know that a lot of amazing science is going to come out of the Artemis missions. But what I was hoping to ask you is something I've put to other NASA officials before is, as a student, how is NASA ensuring that students like me won't be able to have science missions, Earth science missions, astrophysics, heliophysics, other aspects of NASA's budget cannibalized by a human spaceflight program that may not result in a long-term sustainable presence on the surface of the moon or on Mars? How can we ensure that NASA's budget is going to continue to provide things like data to fight climate change? Thank you very much.
So, thank you. So I can say I can echo the words of our administrator, and he said on multiple occasions, part of making this sustainable, and I go back to the first question we had earlier, part of making this sustainable is to not do what you just described. Because once you start doing that, it does become very political, and that's a rough road for us to navigate through. So right now, our senior leadership, our administrator, deputy administrator, they're working very hard to maintain that balance. But it's a long game, right? We do 1-year executable budgets with 5-year plans. They're working that constantly. So somebody else asked me to ensure something, and you're asking me to ensure, but I can't do that for either of you, but I can tell you what we're doing to try to minimize or mitigate the impact of that kind of thing. And at some point, as we continue to make success, and that's on the royal we, all of us, then there'll be less pressures to reduce that budget because people will see the near term or the returns on those investments and the things we're going to do. Okay? All right. Yes?
Great presentation today, thank you. I work for one of the companies that is participating in CLIPS, and it's exciting for us. What are some of the goals for the CLIPS program? What are some of the science that is going to be generated from executing that?
So there's two elements. There's a technology aspect, which I'm going to assume you're familiar with. The idea of how can we demonstrate being able to do a thing or use a technology in another place where we don't have access to it and where we need it to maybe do some things autonomously. So you have that learning aspect. And one could imagine that if I learn how to precision land things at a specific point on the lunar surface, and I learn how to assemble those things at a certain point on lunar surface, then that's a great platform to observe the Earth. So that's science from the Earth. As I can collect samples and measure and monitor them of lunar regolith or whatever's going on, what are the impacts of the rocket plumes as I blow things around, I can understand how I can mitigate those impacts in terms of what comes in with the crew when they're outside the habitable area and inside the habitable area. So there's lots of science, and while we know a lot about the moon and a little bit more or a little bit less about Mars, those are the planets we know the most about to this point, but there's an awful lot we don't know about both of them. So those things will help us as we look again further out beyond into deeper solar system. So there's a long history of science, and I don't want to also leave out the gateway is going to be part of that. Part of the architecture of the gateway will enable science experiments and those CubeSat kind of things, and I say that in general, not literally just CubeSats, but the smaller payloads that we can put on stations on the gateway untended so we can collect that science data. And again, the dark side of the moon, of course, we have a nice shield from everything that's going on in Earth so you can look out into the universe. Okay, did that answer your question? All right. Okay, he didn't put numbers up this time, he just said stop. Thank you.